All right. Hello, friends. So we're moving on. We did objects and arrays, and now we're moving on to our first kind of, what's the word for it? Our first non-built-in data structure, because objects and arrays come standard in the JavaScript language. So we're looking at linked lists today. So linked lists are going to be the first kind of data structure that we look at of non-built-in data structures, ones that we have to build ourselves if we wanted to use them. There's two kinds of linked lists. There's singly linked lists and doubly linked lists. Today we're going to be doing an overview of singly linked lists data structures. So let's get started. Boom. Okay, so what are they? Linked lists are a data structure comprised of a list of nodes that each have a value and a pointer. So the value would be the data that you want to store. So if I wanted to store pretty much anything, numbers, strings, whatever you want to store in there, it has that. The node has the data in it, but the node also has a property on it called next, which points to the next node in the linked list. That's why it's called a linked list, because they all have pointers pointing to the next node. So each list has a head node, a tail node, and the tail node is going to be what's called null terminating, which means that the tail node's next property is going to be null. That's how you'll know that you're at the end of the list. That means that the tail node will point to a null value. So time complexity, let's talk about that. So one of the main things about using linked lists that the reason people would want to use them is because the prepend and the append, prepend would be akin to unshift in an array, for example. And if you remember back to our section on arrays, unshifting in an array has an O of n time complexity. Well, with linked lists, you can do it at an O of 1 time complexity. That's actually one of the benefits of using a linked list, because you don't have to shift all of the elements after it, right? So prepends are O of 1, appends, which it would be like pushing in an array, putting something at the end of the list, would also be O of 1. Now, lookups, inserts, and deletes will be O of n, and we'll talk about that a little bit later. Because you might be saying, like, well, hey, couldn't I insert quicker, or isn't there other data structures to where, like in an array, for example, if I wanted to look something up, it's got an index, boom, I can just look it up. So that's something that we'll have to talk about. So how do they work? So unlike arrays, linked lists, they're not stored sequentially in memory. So if you think back to our array section, basically arrays are stored close to one another, sequentially, contiguously, sequentially in memory, meaning that their space on the storage unit is close to each other. The location in memory for each node for a linked list can be scattered throughout the system. Each list has a partial order between nodes, unlike objects. I shouldn't have put arrays right there. Unlike objects, which have no reference to the other elements. So one of the reasons that one of the main things that people talk about when they're using linked lists is that they're partially ordered. You have partial relationships between nodes. Basically, I know what the next node will be. This allows some advantages as well as some disadvantages. So why would we use them? One of the advantages of using a linked list is that would be partial order that we would get from them. Appending is also an O of 1 compared to unshifting in an array, which would be an O of n. So you can look at this site called Visual Go, Visual Algo, whatever you want to call it. Basically, this shows a linked list, and it gives kind of a visualization of if we want to do it. So let's say that we wanted to insert something. Actually, let's insert, and we'll insert after the tail. So this would be like appending something. And we do that, and that's how it goes. It creates it, and then it points the previous tail's next property to the new tail. So let's say that we wanted to insert here at the head. We would insert here, and in the same way, it creates a node, points its next property to the previous head, and then increases the length by 1. So if we wanted to insert in the center of the node, let's see, specify both. Let's say like this. What you can see is that it has to traverse, then create the node, then point the next property of the current to the new node, and point the new node's next property to the next here. So you can see that traversal and inserting looks like it could be a little bit slower in a linked list, which is true. So let's go back to our, hang on. Man, I thought that would open up in a different tab. Damn it. Okay, cool. So let's see what the drawbacks are. So the drawbacks, while appending operations might be faster than that of arrays, iterating through a linked list or traversing the list is actually slower than iterating through an array. The reason is because, like I said, arrays are stored sequentially in memory, so iterating through an array is faster than traversing, because like traversing in a linked list would be akin to iterating through an array. Traversing is actually slower because the storage of all the different nodes is scattered throughout the system, so actually traversing through it is slower. So since the nodes are not stored sequentially in memory, traversing can be a time drawback. However, as we code out the data structure from scratch, you'll begin to see when and where to use linked list data structure in JavaScript, and then I got this. We'll code one out in the next video, so don't worry. So in the next video, we'll get to where we're coding out a linked list. We won't code it all out in one video because there is quite a bit of learning to do there. So we'll probably just build out the node class, the linked list class, and maybe work on the append method in the next video. So if you're following along with the playlist, the basic programmatic skills playlist that all this is going into, just go to the next video, and then sequentially after that we'll have where we can append, where we can prepend, where we can print out the list of the values within the linked list, where we can insert and delete. And we'll code it all out from scratch, and then we'll do a couple of algorithms that we actually use linked lists in to give you a real-world example of when and where to use them. So hang in there, and we're getting into the fun stuff, so take it easy.